Gentlemen, a very good day to all. I again hope all to be doing good. So now, gents, I would like us to continue with functions. So now this would be intersecting functions, and this would be part one of three. So now, gents, the intersecting functions would be based off equal points. So now these would be points that each graph shares. So this would be your point B. So that's point B over there, where both the f of x graph, which is the quadratic graph, as well as the g of x graph, the linear graph, would be equal at this point. So now the two graphs are also equal at point C as well, as point C would also be a point of intersection. Point A and point B would both be the x-intercept of the f of x function. So remember that to get your x-intercept, you would need to let y to equal 0. So now point D would be the turning point of the quadratic function, the f of x function. So now remember that to get your turning point, you would firstly need to find the x coordinate of the turning point. So remember that the x coordinate of the turning point is also your axis of symmetry. So that's the equation of the axis of symmetry. So remember that that in itself cuts the graph in half. So you would essentially have the left side of the graph as well as the right side of the graph. So now based off that, so that in itself to find your axis of symmetry, you would need to make use of the equation x equals negative b divided by 2a. So now that in itself would give you the x coordinate of the turning point. So now to find the y coordinate, you need to sub in the equation itself, or rather the x value that you would have found there into the original equation. And you should be able to find your y coordinate. So now since point D and G have the same x value, so we can essentially say that they have the same x value if these dots are drawn on them. So now these dots just mean that the angle between the two lines, or the angle that you would form with the positive x-axis or with just the x-axis would be 90 degrees. So that in itself means that the x value for both G and the D would be the same. So that's xg would equal xd. And then obviously that in itself would equal negative b divided by 2a for this case, since it would be a turning point. So now once we've done so, we can then just to find the distance dg. So that would be the distance between D and G. We would only just need to subtract the y coordinate of G from the y coordinate of D. And that would give you the length or the height between D and G. So now we can also determine whether a function is increasing or decreasing. So it's either decreasing or increasing. So now for the quadratic function, it would decrease in other parts of the function, and it would also increase in other parts of the function. So now we can then use the x coordinate of the turning point to deduce in which part of the function itself or of the graph the function is increasing. So now an increasing function would have a positive gradient. So that would be this gradient over here. So if we were to measure from point D, we can actually draw another graph like so. So the graph of this gradient over here, this gradient is a positive gradient. So that would be a positive gradient over there. So because it has a positive gradient, you can then say that the graph increases from point D, from the x value of D, all the way up to positive infinity. So as it goes in that direction in terms of the x values. So we can also do the same thing with regards to this portion of the graph. So that would be this portion over here of the graph. So now this graph that we've just drawn in blue indicates a negative gradient. So that would in itself be a decreasing graph or a decreasing function. So that would be this shape over here. So this shape gives you a negative gradient, and a negative gradient would be a decreasing function. So now the function itself would decrease from negative infinity. So it goes all the way to negative infinity, and it will stop decreasing when it gets to xd. So that would be the x value of d. So we can then say that the this in itself, the domain in which the function decreases would be from, not including, negative infinity all the way up to xd, including. We can then also do the same thing for the increasing. So that would be x is an element from the xd. So that would be from the xd all the way up to positive infinity, not including. So now that in itself was what I wanted to share with you before we head on over to some questions. So I'm going to just move on to the next page for the questions. So now the question reads, or rather the introduction of it reads, the diagram below, so that's the diagram over there, shows below shows the graphs of f of x, which happens to be quadratic, and g of x, which happens to be linear and also unknown. So we don't know the gradient, nor do we know the y-intercept. So now point A, -2:4, is the point of intersection of the two graphs. So that would be that point over there, point A. So now we can also see that point B is also a point of intersection. And point B also looks a lot like it would be a y-intercept. So now that would be, we know that point B would then equal 0 is to whatever y value that is. So now to find the y value, since the two graphs would be equal at point B, we can then look at the f of x graph. So now if we were to make x to equal 0, if that's 0, that's 0, that's 0 over there, we should then end up with the 6. So it then means that the YB would actually just be 0 is to 6 over there, which we also know that the C, since the two graphs share a C, this C over here would also just be 6. So now let's look at 1.1. That's just something I wanted you guys to always check up on before you actually go into the questions. Just look at the graph and whatever anything that seems to be easy to pick up, please do pick up and write on the graph itself. So now let's look at 1.1. 1.1 wants us to write down the equation of g of x in the form y equals mx plus c. So that would be, we need to find the m, and we've somewhat already found the c. So now let's then move on over to the next page for us to be able to do so. So now that would be a is to b. So that's the points that we would need in order to find the gradient of the linear graph. So let's go find the gradient in the next page. So let me just do that. So this would actually be B over there. So now we would need these 2 points in order to find the gradient. So that would be m would equal vyb minus ya divided by xb minus xa. So now this in itself would then just be 6 minus 4 divided by 0 minus 2 over there. This then simplifies to a 2 divided by 2, which then further simplifies to a 1. So it means that the m would then just be 1 over there. So we can then say that therefore, so that's therefore over there, g of x would then equal 1 x plus the c, which is 6. So we would have then sorted out that question over there. So that's 1.1, which wanted you to determine g of x. So now let's then move on over to 1.2, which wants you to write down the equation of the axis of symmetry of f of x. So that would be x equals negative b divided by 2a for this point. So that's that point over there, and you would need to make use of this equation over there. So now let's move on over to the next page again to sort this out. So that's 1.2. So we have x equals negative b divided by 2a. And we know that our f of x equals a negative x squared minus x plus 6. Let me just confirm quickly. So that's indeed the function. So this actually just has to come up a bit, just a tad, like so. So now the b would then just equal negative 1. A would also equal negative 1. So that's a negative 1 over there. So we can then say that the negative 1 divided by 2, and then just negative 1 over there. So that in itself would just equal negative a half. So x would then equal a negative a half, which also happens to be the axis of symmetry. So that's the equation of the axis of symmetry of the quadratic function. So that was 1.2. Let's then move on over to 1.3. So now 1.3 wants us to determine the values of x for which f of x is decreasing. So again, just to do a recap. So now decreasing would all depend on the x value of the turning point over there, which we just found with 1.2. So now this gradient over here going in that direction would actually be a decreasing gradient, or rather a negative gradient. So this is a negative gradient over there. And an increasing gradient would actually be going in that direction. So that's an increasing gradient. So now remember, an increasing gradient, the gradient would be greater than 0. A decreasing gradient, the gradient would be less than 0. So now we can then say that since we are looking for a decreasing function, we can then say that it all starts at negative 2b. So that's where it starts, and then it goes all the way to actually, maybe I shouldn't have done this. I shouldn't have put that there. I should also not put that there. I should only just point at the end there. So I'll just maybe do that. So that's a bit better. So we are more interested in this direction over here. So now based off that, we can then say that the smallest x value that you can find is actually the negative a half. So that's the negative a half over there. And then the biggest y value, since this is essentially going in that direction over there, which is the positive x value, you can then say that it goes all the way to positive infinity. So the smallest x value would be negative a half, and the biggest would be positive infinity. So now to solve, we can then say that the values of x, so that x is an element of, from the smallest x value, so that's including negative a half, all the way to the positive infinity. So that's not including infinity. So now, gentlemen, that's what I wanted to share with you guys today. Please do have a look at the vid properly so that you may be able to attempt the work that does follow. Gents, a very good day to all.